Alright, so in our lesson today on area of triangles, we're going to be given the base and the height of a triangle and asked to find area like you've always done, but not every question is going to be like that. So I thought we would review how do you know you actually have the base and the height, because in our other questions we're not going to have bases and heights on every question. This is what you should already know, so I'm just kind of reviewing. So in a right triangle, the base and the height meet at the right angle. So the base and the height are actually the legs. In a right triangle, the base and height are legs. So that means that two sides of your picture are your base and your height. So if you're going to find the area, doing 1/2 base times height, the base is 5, the height is 3, and so when you multiply 1/2 times 15, you don't get a whole number, but you can get a nice decimal of 17.5. And because this was inches times inches, it'll be inches squared. Now if you have an acute triangle, the height usually is drawn from the top of the picture down to the bottom. Sometimes it's called the altitude of a triangle. And they meet at a right angle. So the base and the height always meet at a right angle, even if it's not a right triangle. So in this problem, we're going to do 1/2 times 3 times 2 for the base and the height. And since 2 cancels out 2, the answer is going to be 3 millimeters squared, because I'm multiplying millimeters by millimeters. Now in our obtuse triangle, your height is always drawn on the outside, because to draw your angle straight down to the bottom of the picture, well, it doesn't, I guess, have to be. It just happens to be the way this picture is turned. Your acute angle, your obtuse angle's down to bottom, and your acute angle's at the top. If your obtuse angle was at the top, it would be drawn more like what the acute triangle was. But they have to make this right angle, so that's your key. The two sides that meet to make the right angle are your base and height, if they're not labeled. So that's 1/2 times 8 times 2. Half of 8 won't be necessary because 2 and 2 cancel, making 8. And then it's going to be centimeters times centimeters, so that's centimeters squared. So this is just a review of how to find the area off of any kind of triangle based on the angles being given. It varies a little bit because sometimes two sides are actually on the triangle. Sometimes the height is dotted in. But not every problem gives base and height. So we have two other methods that we're going to be learning in this lesson. The first one is called the side angle side method. And that method has when you're given a side and you're given another side, but the angle is between the two sides you're given. That's why it's called side angle side. And you take the formula 1/2 times the first side times the second side times the sine and included angle to find that. And the included angle has to be the angle between the two sides, which is why it's called side angle side, or SAS. So I've got 1/2 times the first side, which we'll say is 3 inches, times the second side, which we'll say is 2 inches, times the sine of 110. Now, first of all, it would be great if we could multiply some of these numbers together so that when we do the sine of 110, we'd have something simpler. So the 2's cancel, and that gives me 3 times the sine of 110. Now, I have to have degrees turned on in my calculator to be able to do that, so let's review how to turn on degrees. Well, I'll come back and you'll have to calculate that on your calculator, so because my graphing calculator is not working right now. But you can simply work out that problem, but you need to go to the mode button. Angle needs to be in degrees. So you need to go to the mode button and turn on degrees for this lesson. In fact, this whole chapter we're going to have degrees turned on. We're not going to be working with radians at all. And that'll give you your answer. So I'm going to grab a graphing calculator and get the answer to this question. Make sure my degrees is turned on. And it's not. So 3 sine of 110 equals 2.82. We're going to give a 2 decimal place answer. And then inches times inches is inches squared. So far I seem to see a pattern that when you find area, it's always squared. Now let's look at another example, just to make sure it doesn't matter what kind of triangle I have. This time I have an acute triangle, but it's still side, angle, side, because the angle is still between the two. So it's 1/2 times the first side, 2 centimeters, times the second side, which is 3 centimeters, times the sine of 50 degrees. So again, 1/2 of 2 is going to cancel. That's going to be 3 sine of 50, and not that 3 has to be times the sine every time. It just happens to be the two answers I chose to work with are having that. So 3 sine of 50 is going to be equal to 2.30, and you do have to put the O because it was 2.298 something something something, and that 29 will go up to 30, so you got to show the 2 decimal places, and centimeters times centimeters is centimeters squared. So we're rounding these off to 2 decimal places because that's the standard usual amount. Alright, so it's not hard to fill in that information and multiply 1/2 times the 2 sides, and sine of the angle has to be done on the calculator most of the time. Now, sometimes you don't have any angles at all. Sometimes you have 3 sides given, and none of these sides happen to be the height, because the height would be given down through the middle here, and that's not given. So we're going to have to use what's called Heron's formula. Heron was a Greek mathematician, and he found out that you could do these 2 math calculations, and every time it would work to give you the area of the triangle. So first you have to calculate S, and S is 1/2 times the sum of the sides, so 5 plus 8 plus 10. That's 13 plus 10 is 23. 23 divided by 1/2 is going to be 11.5 meters. Then we're going to fill that in our problem. So A equals the square root of 11.5 meters times 11.5 meters minus the first side, which is 5, 11.5 meters minus the second side, which is 8, minus 11.5 minus the third side, which is 10. Now, sometimes it is easier if you do a little bit of that math all along. I put my meters on all of them because I want to talk about units here in a minute. So I would go ahead and subtract those 2 and get 6.5 meters. Subtract those 2 and get 3.5 meters. And subtract those 2 and get 1.5 meters. Now I'm supposed to multiply that all together and square root it. So that's where your handy dandy calculator comes in. Just like that handy dandy notebook with Bob the Builder. No, Blue's Clues. Handy dandy notebook with Blue's Clues. 11.5 times 6.5 times 3.5 times 1.5 comes out to be this number. Not that it's really all that important to write it down, but I'm going to write it down just in case I make a math error. And then, after you take the square root of that answer, you get 19.81. Now, we know it's supposed to be meters squared, but I want to show you that his formula really works by doing the units. So meters times meters times meters times meters is meters to the 4th power. And the square root of a 4th power halves the power makes it meters squared. So it even works with the units. So it's 2 calculations, but it gives you the area accurately. Heron was a really smart mathematician for somebody who could never use anything really high-tech to do the math calculations. Not like they had calculators or slide rules or any of that to help them do the calculations. They did it all by hand. So let's look at one more example of Heron's rule. So in this one, I gave you an equilateral triangle, and I can tell that because all the sides are marked equal, so I know they're all 8. So S equals 1/2 8 plus 8 plus 8, because it says add all the sides together and half it. Now you'd think you'd add them all together and divide by 3, but that would be an average. And we're not averaging. We're doing a math calculation based on a long, drawn-out calculation that someone came up with this formula on. So that makes 24 when you add it up, and half of that's 12. And since that's feet plus feet plus feet, it's still feet. Now let's do the square root. So the area is equal to the square root of 12 feet. 12 feet minus 8 feet. 12 feet minus 8 feet on the second question. And 12 feet minus 8 feet on the third question. Well, at least this was a lot more consistent on the numbers, so the math was really quick. So this is this 12 times 4 times 4 times 4. The first number's in feet, the second number's in feet, the third number's in feet, and the fourth number's in feet. So that's 64 times 12. Let's see what that is. 64 times 12, because 4 times 4 times 4 is 64 times 12. So that's 768, and then if we take the square root of that, that's 27.71. And again, this is feet to the fourth power, and half of that is to the second power, is how they got the units to work out correctly as well. So this is two new ways to find the area of a triangle from what you're so familiar with back in elementary school when you first started trying to find the area of different shapes. Triangle was one of them. But now we have two new ways to do it because we don't have to be given the base and the height. And that's kind of good because the height is sometimes not even a number on the side of the picture. Sometimes that number is just totally not something that we are given at all. So it's always good to be able to find that. So in your homework assignment, you're really going to focus more on the side angle side rule and the side rule. And I am going to assign you 12 problems to do. Let me write this up for you. So 7.4 is going to be in Canvas. It's actually page 561 out of our textbooks. And you're going to do problems 2 through 24 even. So I'll have to scan this and put this into Canvas for you since we don't have any textbooks handed out anymore so that you can do the assignment. But when you take a quiz on this, I may throw in that 1/2 base times height to see if you're paying attention to, oh, I can do that one the way I've always done my problems. So that's your assignment, and I will scan it and put it in Canvas, so you should be looking for it in Canvas.